All right, advanced placement calculus, time for another instructional video. Continuing with our AP review, a little bit of housekeeping. The views are not high enough on these videos, okay? So not enough of you guys are actually watching these. I guess I'll put a note on my website because if you're not watching them, you're not hearing my word of warning right now. But anybody who is watching and has friends who are slacking off, tell them to get on the ball, okay? You had an assignment, that was assigned on Monday, I think, okay, due Friday. Who could remember what day it is, okay? The day we're doing right now, not even sure which day's lesson this is, but if I look at my information over here, so this would be what we're doing on the 22nd, so this would be Wednesday's lesson right here, okay? So I think I assigned a take-home. I think the take-home was assigned either on Monday or Tuesday. I don't remember, okay? I think it's actually Tuesday. So let's rock and roll and get to the next topic here, okay? So remember, if you got friends who are slacking off, look, put in the work, okay? If you slack off during this AP review, you're not going to get anywhere on the AP exam. Don't forget the fact that you guys have college next year and things like that that are very important. So what we're talking about today is we're talking about integrate the rate, little star action, integrate the rate. Very, very popular on the AP exam, okay? They're primarily calculator-based questions, and your AP exam this year, technically, they said you won't need a calculator for any question, but still, they could easily give you a question like this. The reason that they have calculators are usually these rates of change are so filthy, integrating them could be a real problem, but they could have you just set up formulas and stuff and not actually go to the answer. So who knows? This is usually a hot topic, might easily be a hot topic on your AP exam. Integrate the rate. Remember, if you integrate the rate at which a quantity changes, you get the change in that quantity. If you integrate the rate at which people contract the coronavirus, you'll find out the change in the number of people that have contracted the coronavirus, okay? Which is actually how many people have gotten the coronavirus. Here, if you look at, 2004 Form B, calculator question here from your packet, they say from 0 to 31 for T, the rate of change of the number of mosquitoes on Tropical Island, that's my favorite right there. Let's have like a really cool tropical resort. What are we going to name this thing? Let's name it Tropical Island. Wow, what a great idea. The rate of change of the number of mosquitoes on Tropical Island, that's not even an important piece of information. I don't know why I boxed it in, whatever. At time T days is modeled by this guy right here, R of T, and that's the rate of change of the number of mosquitoes is represented by this right here. Remember, if you integrate the rate at which the number of mosquitoes change, you'll actually get the change in the number of mosquitoes on the island, okay? How many mosquitoes did it go up by? How many mosquitoes did it go down by? A lot of times there's entrance rate and exit rate. They'll give you the rate at which the mosquitoes enter the island, bzzz, and the rate at which the mosquitoes leave the island, bzzz, okay? And you'll need to actually subtract the exit rate from the entrance rate to get the true rate of change. They don't do that here. They just give you the true rate of change. They also give you a niche condition. It's if the change in the amount of mosquitoes on the island. Hey, it went up by 50 mosquitoes, went down by 12,000 mosquitoes. That doesn't tell you how many mosquitoes on the island unless you actually have an niche condition, okay? And that's it right here. 1,000 mosquitoes at time T equals 0. T represents days, so it looks like we're looking at a month here. We're focusing on this island. It's not always about integrate the rate with these problems. Part A, which is Part A. Show that the number of mosquitoes is increasing at T equals 6. Well, number of mosquitoes increasing, remember, something increasing, surely there must be some sort of test, okay? And that's the first derivative test. But if you want to know if the number of mosquitoes is increasing, you got to check to see if the derivative of the number of mosquitoes is positive, okay? And the derivative of the number of mosquitoes, think about it. What does the derivative tell you? It tells you the rate of change of something. So if you take the derivative of the function that represents the number of mosquitoes, you'll get the rate of change of the number of mosquitoes. That's actually R of T. If we had a function that represented the number of mosquitoes, which you can come up with if you want to, maybe we'll do it later. If you took the derivative, you would get R of T, okay? So the problem is a lot of people are like, oh, you got to take a derivative and plug in 6. No, you're already given the derivative, okay? R represents the rate of change of the number of mosquitoes. Let's see if it's positive at T equals 6, which means it's time for the TI guy. How you doing, TI? What up? Okay, so here we have 5. You'll see some nasty, types of functions with the calculator, obviously. Radical T, so radical X in the calculator. Now we got cosine of the quantity T over 5, so X over 5. Okay, I'm going to take this thing, and I could easily numerically evaluate a derivative on my calculator. Okay, we go to the quit screen. Remember, I had a dog named Math. I fed him. Math 8. That's my daughter screaming upstairs. Okay, so let's actually take the derivative with respect to x of, wait, actually, I don't want to take a derivative here. What am I doing? Okay, I already have the derivative inside my calculator right here. So what we're going to actually do is just plug right in, little alpha toithi, y1, and let's evaluate that at x equals 6. T equals 6 in this particular case, right? And we get 4.438 right there. And you can see that that number is positive, okay? So if the rate of change in the number of mosquitoes is positive, that means the number of mosquitoes is increasing, okay? So number of mosquitoes increasing because, and they always want you to justify it, you know, it says show that the number of mosquitoes is increasing. So it kind of implies that you have to justify here. But look, because the derivative of the number of mosquitoes is positive, because R of 6 is greater than 0. So be careful. To use the first derivative test, you don't always need to take a derivative. Sometimes they give you the derivative. And then part B gets really funky with the language. At time t equals 6, same time, is the number of mosquitoes increasing at an increasing rate? Or is the number of mosquitoes increasing at a decreasing rate? Give a reason for your answer. And people are like, what the heck is going on? Well, we know the number of mosquitoes is increasing at t equals 6. Now we want to know the number of mosquitoes, is it increasing at an increasing rate? Or is the number of mosquitoes increasing at a decreasing rate? Okay, and now we're talking about the rate of change increasing or decreasing. And remember, if you want to know when anything is increasing or decreasing, take the derivative of that thing. But now if we want to know that the rate of change increasing or decreasing, we got to take the derivative of the rate of change. That's why it's r prime of 6. Okay, you know, a lot of people, they would actually do this for part A, which is incorrect. They gave you the first derivative. Now they actually really want to know the concavity of the original function. You know, if you're increasing, are you getting steeper or are you getting less steep? Okay, increasing at an increasing rate would be increasing concave up, and increasing at a decreasing rate would be increasing concave down. All right, so look, you know, it's a little wordy there. I think if you think about it too hard, it actually makes the problem a lot more difficult. Sometimes you kind of want to go with first instinct. Anyway, now I had a dog named Math. I fed him Math 8. Let's do the derivative with respect to x of y1 evaluated at x equals 6. Now I get negative 1.913. So now I already know that the number of mosquitoes is increasing, but now I know the rate is decreasing, okay? So mosquitoes increasing at a decreasing rate. Mosquito, who knows how to spell? Not me. Mosquitoes increasing at a decreasing rate because, little justification, r prime is 6 less than 0. You don't always get questions like this with integrate the rate. Sometimes they ask you stuff like this, sometimes not. That can bother people a little bit there, but that's 3 points, okay? And you should be able to get, you know, at least a few points out of that 3 right there. Part C is a little bit more, you know, what we're used to dealing with these types of problems. According to the model, how many mosquitoes will be on the island at time t equals 31? Round your answer to the nearest whole number. So now you actually need to know the amount of mosquitoes at t equals 31. Remember, if you integrate the rate at which the number of mosquitoes change, you get the change in mosquitoes. You know, how many mosquitoes did the island go up by? How many did it go down by? Remember, that's useless if you don't start with some initial amount. And they tell you at t equals 0 that there's 1,000 mosquitoes on here, okay, on the island. Must be a small island. Okay, so t equals 0. We know there's 1,000 mosquitoes. I just want to know, what the heck was the change in mosquitoes? Okay, starting at t equals 0, in this case, ending at t equals 31. And once again, if you want to know the change in the number of mosquitoes, you integrate the rate at which the amount of mosquitoes change, okay? And it's just the fundamental theorem of calculus, just like we did yesterday, like even in your homework, right? You know, if you had like f of 0 plus the integral from 0 to 2 of f prime of x with respect to x, that's exactly what's going on here. You don't need a mosquito function. If you want, you could let m of t equal number of mosquitoes on island, number of mosquitos on island at time t. And you could come up with the function for it if you want. You could say, okay, let's start with m of t. Let's start with 1,000. That's the number of mosquitoes that are there at t equals 0. Want to know what the heck was the change in the number of mosquitoes starting at t equals 0 up to some other t value, right? We're just getting a function in general here. And if you want to know the change in the mosquitoes, integrate the rate at which the mosquitoes change. See, technically right there, that r of t, if m represents the number of mosquitoes, that's really m prime of t. That's the exact same thing, okay? So you could have even said m of 0 over here if you want to. But this is the function that tells you how many mosquitoes are on the island. I messed something up, right? Did you notice that? T here can't be a t here. It has to be an x. Got to use a dummy variable. All right, but once again, if you want to know the amount of mosquitoes at t equals 31, you could take out this t, you could replace it with a 31, just like we have over here. We have r of t dt in the integral. They have r of x dx. It's the same exact thing, okay? So look, you could do that, and that could become interesting, like if they wanted the maximum, the minimum value of mosquitoes, which I think comes up in the next problem, you could take this thing and take the derivative here. But you might notice if you do take the derivative of 1,000 is 0, plus, this is an accumulation function, right? To take the derivative, drop in the t. For the x, integral sign goes away, dx goes away. And you'll see that m prime of t equals r of t, just like we said before. Okay, so look, it's not as complicated as it seems. I know it seems kind of nasty. By the way, let's get an answer here. And they also said round your answer to the nearest whole number. So truncators, beware. This question right here is worth 2 points. Okay, part C. Could you imagine if you actually only got a point for it because you forgot to round? I mean, that is not a situation, little math niner, that is not a situation that you want to encounter on the advanced placement exam. Okay, so anyway, over here, it looks like to the nearest whole number. Little thinking here, right? Complicated functions and stuff like that. And these new calculators take so much longer than the yellow calculator. So if you have a yellow calculator, you probably already have your answer. I get 964 mosquitoes. You know, always put units. Units. I need units. What are the units? Mosquitoes. Okay, because they want to know how many mosquitoes were actually there. So C. Hopefully not too horrible, okay? You know, it's not really a traditional integrate the rate problem. We'll do one of those next, but it's not a problem that's bad. Part D, to the nearest whole number, what is the maximum number of mosquitoes from t equals 0 to t equals 31? Show the analysis that leads to your conclusion. Maximum number of mosquitoes, just think about it for a second. Isn't that really important information? Like maybe it's a popular month for a tropical island, you know, and you have a resort there. Maybe you want to know on what day the number of mosquitoes is maximized, and then when the number of mosquitoes is at a minimum. It's a good time to have like a picnic on the beach. Anyway, it's the nearest whole number, maximum number of mosquitoes. Maximum number, well, surely there must be some sort of test. And we know it's the first derivative test. Just remember, it's the first derivative of the function that tells you the number of mosquitoes. They never gave you that function, okay? We have it over here. We know when we took the derivative, we got r of t, but you don't need to do this work, okay? They specifically tell you r of t represents the rate of change in the number of mosquitoes. So if you wanted to draw the number of mosquitoes derivative line, that's the r of t line. Is it bounded? It is, from 0 to an age I wish I still was, 31. Okay, and look, the best way to draw r of t is the line is to actually graph it. You have it in y equals right over here. You got a domain, for crying out, math. Ba-na-na-ba, she came in through the bathroom window. Let's go from 0 to 31 and get a little zoom 0 going on, okay? And remember, this is about to graph r of t. Anytime. Are you telling me I want to draw the line for the graph that I'm given? That's when you check above and below, and you can see we start out above. Then it looks like we're below. Are we above again? It's happening here, folks. Does it ever dip down below? I don't think so. These are places where r of t is equal to 0. So the rate of change in the number of mosquitoes is equal to 0. So if you graph the mosquito function, it would have horizontal tangents here. The first one I care about, right? Because I want a maximum. But the second one I don't care about. So I don't need to calculate that 0. But I need to calculate this first 0 over here. Let's go bug, a bug, a bug, a bug, bug, bug. And over on the right. Okay, and its guess is what? 7.854 approximately. But it also wants to know the x. It just wants to know what is the number of maximum number of mosquitoes. So you're gonna have to figure out the amount of mosquitoes at each time where there's a max and compare the values. So I don't know why I'm saying that right now. We'll talk about it in a second. At 0, function starts immediately increases. That's a min. I don't care. But at 31, the function increases and stops. That's a max. So I care about 31 and 7.854. So I know we got maxes. And we know 1 is at t equals 31. That one doesn't need to be justified. It's an endpoint. It's always implied there's going to be extrema and endpoint. But also at t approximately 7.854. And you should justify, right? Because r equals 0, pardon me, no prime. So I'll turn this into r of t equals 0 and changes from positive to negative. All All right, and look, now I actually need to figure out the amount of mosquitoes at each time. And I know at t equals 31, the number of mosquitoes, I already did that, okay? What I got, like 964. That's the rounded value. Okay, 964, I'm writing 46, my dyslexia is kicking in there. So 964, that's the rounded value, but it doesn't matter because I just want to compare Y values here. Now I need to know how many mosquitoes are there. At T is approximately 7.854. And this here, you're going to have to show the work for, and it shouldn't be an issue. I don't know how to spell anything here. Shouldn't be an issue. It's just like what we did over here. Okay, so that's going to be 1,000. The number of mosquitoes at t equals 0. What the heck was the change in the number of mosquitoes from t equals 0 up to t equals 7.854? So that means we want to integrate the rate at which the number of mosquitoes change. Okay, and this is where, if you go to the quit screen, you hit X, you hit enter, that's that value. You can't use a rounded value up here. You could still keep it as X, but sometimes that gets a little funky because when you do indefinite integral, you got the dx there. I've seen weird things happen. There shouldn't be weird things that happen, but I've seen it. So I'll store it in for alpha A, and I'll save time. Saving time in the AP exam is so important. So you have this set up right here. Now all I need is alpha A right there. And the number of mosquitoes, which you could even round to the nearest whole number, takes so long. You know, these newer calculators, they're a lot slower, okay? People don't understand when I start to, you know, scream and yell about it, but those old yellow ones, much quicker. 1,039. It's also a partial part of a name from an old school Green Day album. Really cool. Hey, 1,039 mosquitoes. So now we actually want to know the maximum number of mosquitoes. Well, first you got to say when the max occurs. So max number of mosquitoes, I'll put it here. Max number of mosquitoes at T is approximately, and we could see it's, 7.854 units, right? So where's that? Days. So between the 7th and 8th day, because you got to justify, okay? And really here you could say M of 31 is less than M of 7.854. You probably say M of 7.854 less than M of 31, but that's only if you made the function that represents the number of mosquitoes. You could just say if you want, because, 1,039 is greater than 964. I know it seems silly. And don't forget to answer the question. They actually want to know the max number of mosquitoes. So the max number, that's actually going to be your 1,039 mosquitoes. So be careful whether it's applied or abstract problem. Absolute maxes, absolute mins. Sometimes they want to know when they occur. Sometimes they want to know what they are. If they want to know what they are, you got to talk about when they occur first. Okay, so be careful. Not too terrible a problem. I get it though. You're probably like, oh, this is overwhelming. It's not so easy. It's not supposed to be, and you're not supposed to be getting maximum points on all these questions. Okay, that's what you have to understand. You want to try to get as many points as possible. These are worth 9 points. If you want to get a 3, you're talking about 4 out of 9 points. Okay, like I said before, 5 is about 7 out of 9 points. So even if you're going to get a 5, you're not going to get every part of these questions right. Even though that previous question, you could have got 9 out of 9 on. And some people are like, oh, I'm going to ace the AP. Well, there's going to be another question when you turn the page where even really good kids might only get 3 or 4 points out of 9. Obviously, it's different for you this year, but it's something to think about. 2013. The year Mr. Berto got married, okay? Here we have another problem with the graphing calculator. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant, what's going on here, is modeled by G of T, where T is measured in hours from 0 to 8. At the beginning of the workday, T equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. So look, it's made to be out more complicated than it is here, okay? Unprocessed gravel. So gravel arrives at this gravel processing plant at this rate. If you integrate the rate at which the gravel arrives, you'll find out how much gravel arrived, but it's unprocessed, okay? Then they say during the hours of operation, 0 to 8, the plant processes gravel at this constant rate right here. What you have to understand is that this is the entrance rate, okay? It's the rate at which the gravel is arriving. When the gravel is processed, that means it's going to leave the plant, okay? So that's actually the exit rate. Not so easy to see that this guy right here is your rate in. And this guy right here, it's a constant rate. That's the rate out. And then, by the way, did you notice the initial condition? T equals 0 at the beginning of the workday, 500 tons of unprocessed gravel. So your mind should be working here. You know, if I integrate the rate at which the gravel arrives, I'll find out how much gravel arrived. If I integrate the rate at which the gravel is processed, I'll find out how much gravel was processed, which means it's essentially leaving the plant. You know, part A, which is a part A. They just say find G prime of 5, then using correct units, interpret the answer in the context of the problem. Very popular on the AP that they'll either ask you to evaluate a derivative or an integral, you know, a definite integral, and then explain what that means. And it says in the context of the problem, but you could still be pretty generic about it, believe it or not, as long as you put your units in. So G prime of 5, you're going to get points for just doing G prime of 5. So if you're the type of person who's like, this question's too complicated, I'm not even going to try it, you're giving away free points right here, okay? You know, free points, you can get a point just for G prime of 5, just for G prime of 5, so G of T, 90 plus 45, low cosine, low alpha y equals for G quiz, all right, x squared over 18. Okay, so now G prime of 5, so G prime of 5 approximately, is approximately, you know, we want to take the derivative of G of T. Remember, G is a derivative, but apparently we want a derivative of a derivative. Describes concavity of the original, but increasing and decreasing of what you took the derivative of, the rate of change of what you took the derivative of. So math 8, derivative with respect to x of alpha 20, y1 at 5. All right, so I get approximately negative 24.588. You could put units down for it right now, or you could put it in the explanation. You know, whenever we explain a definite integral, we always start with the change in, right? Because that's what a definite integral represents. This is not a definite integral. It's a derivative, and a derivative represents rate of change. So the second on the AP exam, if you want to describe a derivative, you start with rate of change of every single time. And then you're like, oh, what the heck did I take the derivative of? What did that function represent? Well, G represented the rate at which unprocessed gravel arrives at a gravel processing plant. So we just got the rate of change of the rate at which unprocessed gravel, unprocessed gravel arrives at the plant. And look, it seems like a lot of words, but don't think about it too hard, okay? You know, this is the rate of change of, what does G represent? The rate at which unprocessed gravel arrives at the plant. Now we got to say units, okay? And just remember, G was in, T is measured in, so it's the rate in tons per hour. It's right here. Okay, so G is measured in tons per hour, but now we're taking the derivative of it with respect to T, because it's in terms of T. So we're getting tons per hour, okay? And that's actually tons per hour squared. So tons per hour squared. It's kind of like an acceleration right there. And then you also want to say at T equals 5 hours, okay? Which actually means at the end of the 5th hour. That's when T equals 5 occurs, when the 5th hour elapses, okay? So look, you could say that the rate of change of the gravel is actually decreasing. You could say things like that, but it's not necessary. You could just say the rate of change of the rate at which the unprocessed gravel arrives at the plant in tons per hour squared at T equals 5 hours. You can keep it generic. You don't have to explain exactly what that means about the plant, okay? The fact that the rate of change, you know, the rate at which the gravel is coming in happens to be decreasing at that point. You don't need to really explain that. It's cool to get into stuff like that, but it's not needed on the AP exam. You could always keep it generic. Part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. Come on, if you want to know how much gravel arrives, you integrate the rate at which the gravel arrives. This is supposed to be the gimme part of the question. It says during the hours of operation, which is 0 to 8. Don't be adding 500 to that. I don't want to know how much gravel is there. I just want to know the change in the amount of gravel that arrives, okay? And that's what happens to figure out the amount of gravel that arrives. Let's integrate the rate at which the gravel arrives, low math 9er, and nothing could be finer. Okay, low alpha 20, y1 with respect to x. Okay, and I'm going to get approximately, and what do they say here? Do I want to round? Okay, find the total amount. It doesn't say to round, so approximately 825.551 units. I need units, and it's giving us the amount of the gravel, and that's going to be in tons. Okay, you know, you could also think about it with, you know, if you integrate, you multiply units, you're integrating tons per hour. With respect to hours, you're multiplying by hours. These cancel out. That's why you're just left with tons right there. But it should kind of make sense commonsensically. Part C is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5 hours. Show the work that leads to your answers. Increasing or decreasing, I mean, surely that must be some sort of test, okay? It's the first derivative test. You want to take the derivative of the function that represents the amount of unprocessed gravel at the plant. Okay, because we want to know if that's the thing that's increasing or decreasing. They never give you the function that represents the amount of unprocessed gravel. They just give you the rate at which the gravel comes in and the rate at which the gravel comes out. Okay, now remember, you want the rate of change of the amount of gravel in the plant, right? You know, the derivative of the function that represents the amount of gravel in the plant, which you can come up with if you want to. It's kind of like that mosquito function we came up with last problem, only you'd be adding an integral and subtracting an integral because you got to focus on entrance rate and exit rate. But remember, you just want the rate of change of the amount of gravel in the plant. So rate of change of amount of gravel in plant. And remember, if you want the rate of change using an entrance rate and an exit rate, it's always going to be entrance rate minus exit rate every single time to get that true rate of change. Rate in minus rate out. See, last problem with the mosquitoes, they told us the function that represented the true rate of change. Inside here, it had entrance rate minus exit rate. Okay, that's not true here. Here's the rate of change, the amount of gravel in the plant. I want to know if this thing is positive or negative at t equals 5. That's going to tell me if the amount of, gravel is increasing or decreasing. So I really want to do g of 5 minus 100. Okay, so g of 5 minus 100 in our calculador. We'll have to tweet the y1 of 5 minus 1 hundo. Okay, and I get approximately negative 1.859. Okay, and this right here is going to tell me the amount of gravel at the plant is actually going to be decreasing. Okay, so amount of gravel, of unprocessed gravel, at plant decreasing. Because its rate of change is negative, and that's g of 5 minus 100 less than 0. You could also just get what g of 5 is equal to if you want to, and then you can figure out if it's greater than 100 or less than 100. It's the exact same thing, okay? And there'd be nothing wrong with that. You could say, I know it's going to be it's going to be less than 100 because this answer is negative right here. So you could say amount of unprocessed gravel at the plant is decreasing because g of 5 is less than 100. You could say it that way, and that makes more common sense, but this is really important to be given an entrance rate and exit rate and to figure out how to get the true rate of change, because that's important for part D when you want to know what's the maximum amount of unprocessed gravel at the plant. Surely there must be some sort of test, and there is, okay, the first derivative test, but you want the maximum amount of unprocessed gravel, so you need the function that represents the amount of unprocessed gravel. We don't have it, okay? If you want, you can come up with it. It would be 500 plus the integral from 0 to t of g of x with respect to x minus the integral from 0 to t of 100 with respect to x, okay? But if you take the derivative of that, it'll give you the rate of change of the amount of gravel in the plant, and that's g of t minus 100. So you don't need to come up with that function that tells you how much gravel is there. Let's just get the rate of change. We already have g of t minus 100 from 0 to 8. And if the amount of process, I don't know, maybe a of t was the function that represented the amount of gravel. This would be a prime of t right here. Let's graph this thing. I'll turn y1 off. And down here in y2, I'll put y1 minus 100. Maybe I will. Okay, why aren't you working? Whoa, it's not turning on. Wow, so weird. Oh, you got to have something in there first. I'm losing my mind. All right, so the alpha twaithy. So you turned on automatically. Y1 minus 100. And now we know we can go from 0 to 8. A little zoom 0 action. And remember, I want to draw the line for the graph that is surely being created soon. We can see it starts positive, and then I believe it becomes negative. And right here is the part where it's equal to 0, which is sweet, okay? Because that's a place where there's a maximum. The two endpoints are min, so I don't even care about them. But I definitely care about this 0. I'll calculate it. And remember, this line right here, it's never justification for anything. It's just a way for you to actually organize your information. But it's a great way to do that. So I would I would draw the line if I were you. 4.923. So now we know that we got max amount of unprocessed gravel. Why couldn't they just talk about gravel entering and leaving? Why they have to talk about it being processed? So I have to write this word that I can't spell 100 times over and over again. Max amount of unprocessed gravel, we'll say at T is approximately 4.923. Don't forget about those units. That's hours. And then you got to justify. And here it's because the derivative is equal to 0. G of T minus 100 equals 0. Don't forget about that crit point. N changes from positive to negative. Sometimes they just want to know when there's the maximum amount of unprocessed gravel, but here they actually want to know what the max amount is. So we got to calculate max amount. And remember, we got to take the amount that came in and subtract from it the amount that left. But we also have to start with that initial amount of 500 tons. And let's add to that the amount. Remember, this is T equals 0, 500 tons. So how much, gravel arrived from T equals 0 to T equals 4.923? Well, let's integrate the rate at which the gravel arrives. And then we want to subtract from that the amount of gravel that left, that was processed. So that's from 0 to 4.923. And to find out how much gravel was processed, integrate the rate at which the gravel is processed. You actually don't need an integral for this right here. You could just do 100 times this number because it's a constant rate of change. It's really up to you. Nothing wrong with actually using the integral. But anyway, back to the calc here. 500, fishundo, plus a little math niner. Ooh, you know what? Before I do that, let's hit X and hit enter and store this thing in for alpha A. All right, remember, use the entire value. 500, fishundo, plus a little math niner, integral from 0 up to alpha A of, whatever is in, what do I want? It was in Y1, right? I don't know what's happening right here. Okay, let me just check, right? There it is. Okay, so just be careful with stuff like that. So I do want Y1 here. It's easy to have a different function. Maybe, you just have Y1 and then you put the minus 100 on the end. You didn't create Y2. So be careful. Minus the amount that was actually processed. A little math niner from 0 to alpha A. And now of 100. Constant rate of change right there with respect to X. Did they say nearest whole number? No, just the actual maximum amount. All right, so I get 635.376 units. I need units. I think it's tons right there, okay? So hopefully not too terrible of a situation. Remember, instead of doing this, you could have did 100 times the 4.923, but make sure you use the true value there. Otherwise, the answer is going to be incorrect. Integrate the rate's not too terrible. Just remember, if you're given an entrance rate and an exit rate, you want to subtract them to get that true rate of change. Definitely some filth coming up on the homework problems tonight. There are 3 of them. Okay, remember, think about actually, accumulating points. Accumulating points, right? The accumulation function right here. That's pretty apt. Do the best you can. Okay, fight your way through them. A couple of them are tricky. I know the one with the young lady. I think her name's Janet. I don't know if it's Janet. Jane? Something like that. I think it was a J. She's shoveling snow. Problem becomes a little tricky because of the algebra. Okay, so do the best you can and check in tomorrow, obviously, with another video. We'll do this another day, integrate the rate day 2, because it's pretty important, pretty popular on the AP exam. Your AP exam is a little bit of an outlier, but we're going to do what we do, and then we'll focus more on stuff toward the end of AP review. This is Berto signing out, y'all. Adios.